So we have our pieces. Let's make sure actually that the cutters are pointing to the correct cutters. Something got a little messed up here. So after we merge these, we can drop down in null, and this will be our cutters. So let's make sure that our object merge is pointing to the combined cutters here. So let's recache this now. Save to disk. All right, so now we have our pieces. Perfect. With these pieces, I will Control C. Let's grab this, and over here to the right of this, we will create our points chain, and to the right, we will create our curves. So let's do an object merge, place our pieces here, and maybe it's worth just encapsulating everything here and just keep things a little bit more organized. Maybe I will do Shift O, or actually I think it's Shift P, all right, to drop down a sticky note, and this will be our fracture. And let's right click, set this to medium size, scale this so we have our fracture. Let's copy this sticky note, bring this over here, and this is our boolean op for operation. You can name this however you want. I'll press Shift O, encapsulate this. Okay, and we can start working on the with the pieces. So right away we'll just do an extract centroid. So now we don't really have to worry from here on out about any geometry. We will just work with points. Let's drop down a null from here. So this will be our start points, or I guess a more suitable name would be here rest points, but let's just go with start points. So I'll grab this, let's grab the start points, and over here below, let's do our transform pieces setup. Let's drop down this transform pieces SOP, place this here, drop down an object merge, and bring in our start points. All right, so this over here. Let's copy this and let's grab our pieces again. Control C, bring this over here. So our pieces will be the pieces that we want to, the geometry that we want to transform. And we have our rest points, which is our start points. So if I look at this, nothing's happening, and we have to create our template points. Okay, so the points that move. For this, we will first need to determine their end position. And in order to do this, we will first need our ground geometry. So we can create this in a separate container, but I think I will just maybe create this somewhere over here. I'll just make a little bit of room. For the ground geometry, we will keep this super simple. You can get as complex as you want, but let's just drop down a grid for now. And I want to make this a 30 by 30 grid, and let's increase the rows to 50 and 50. Let's check this out. Okay, from here, let's right away drop down a texture node. Let's also use a UV quick shade. By default, the default settings here should be fine. So if I preview this, everything looks good. All right, and I just want to subdivide this to add a little bit more resolution. Maybe I'll do two subdivisions here, and let's just drop down a mountain, and this will be our ground basically. I will maybe let's use sparse convolution here, and in the fractal I want to increase the roughness a little bit. Maybe I want to do 3 levels of subdivision to just have enough geometry. Maybe I'll just increase the size. So we will keep this, like I said, really simple, because most of the look of this terrain will be carried by the Megascans texture. So we will have all of the bump and displacements effect that we will need to make this ground look believable and realistic. I think this will be fine. We can also play around with the amplitude, but really I want to keep this fairly flat, just because I want to keep this setup as simple as possible, because there are a lot of steps involved here. But just note that this technique should work with any kind of terrain or ground or geometry. So let's drop down a null from here, and this will be our ground, and I like to call this GR and D. I will encapsulate this again, and maybe I'll drop down another one of these sticky notes here. Let's go ahead, place this here, and this will be our ground geo. All right, so now we can use this. So let's grab this. Let's copy an object merge, bring this over here. Okay, so we have our starting points and we have our ground. So essentially what needs to happen here is we want to ray these points to the ground. So if I just drop down a ray sop, place the ground as the second input, and I can set the method to minimum distance. And let's turn off show guide geometry. This might as well be our endpoints. Let's drop down in null. Of course, we will do some changes to this, but let's just say that this will be our endpoints. So rename this. And now, like I mentioned in the demo video, we have our start points, we have our endpoints, so we can create a curve that connects these two sets of points. Let's actually just copy an object merge here, grab the start points and place them here, and then do another copy of this and bring in our endpoints, paste this over here. So again, start points, endpoints, we merge these together. So now they're both in the same geometry, and we can drop down and add. And because these have the same name, we can go ahead and let's connect these by group, and the attribute will be name over here. So for now, let's drop down in null, and let's say that this will be our curves. And now we'll keep these curves as they are without doing any operations for now. And let's go ahead and animate the points along the curves. So these endpoints over here. Let's go ahead and duplicate this object merge, bring in our curves, so Control C. Let's bring this over here so we can work in this chain. And we will do an attribute VOP. Let's point to our curves, or rather use it as our second input. So this will be our driver, and we can even press C and let's color this red. And inside here, we will do the exact same thing we did in our demo video. But actually before that, let's go up and let's not forget that we want to promote the name attribute, which is currently at the point level. We want to promote it to the primitive level. So let's not forget to do this. This is a very important step. Let's drop down the attribute promote, point to primitive, attribute will be name. All right, so now we can do our driver. Let's step inside here, and from op input tool, from our curves, we want to drop a find attribute value. All right, and we want to import the name attribute that's currently on our points. So we will simply do a bind for this. Type will be string. Name will be name. And this is the search value. So again, to reiterate this, we want to find the primitive number from the curves which has the same name attribute as our point. So this name attribute here is what's on our point, and we want to use this attribute as the search value on our curves. The attribute class that we want to find is going to be the primitive class, because remember that we promoted the attribute to primitive, and the attribute will be name. All right, so the result of this will be the number of the primitive which has the same name as our point. So I already said all of this a million times now, so let's just do let's just continue with the setup from here. We want to use the primitive attribute. Let's grab the primitive attribute from here. From our second input, we want the attribute to be P because we want the position, and the element ID will be plugged inside this primitive value over here. So if I just simply place this inside the position here, we can see that this they snapped to the end position because we have to turn this around, but essentially now we have this U coordinate which we can animate that goes from their their end position to the start position. Let's go ahead and automate this animation by fitting the frame value. So from the frame, let's drop down a fit range, and let's plug the result inside our U coordinate. And the source max, maybe we want to promote this, so I will middle mouse button and promote. This is essentially the duration of the animation. And like I mentioned, this value should go from 1 to 0 rather than 0 to 1. So let's just reverse the values here. All right, so now if I go up and I increase this value here, let's maybe say that we want our animation to be 100 frames. I'll set this here to 100. We can see that over the course of 100 frames, they move back to their position and they are actually on these curves. So again, if I were to come here to this the curves, let's drop down a resample and let's add some more points to work with. I believe a value of 0.1 should be fine. But for example, I can grab now any point from here, and if I move this over like this, I'm using the scroll wheel to increase the soft selection. And if I now look at my driver here, we can see that there is a point right on this curve. So now I can drop down a null from here, and let's rename this to anim PTS, and this will be our template point. So I will Control C, and let's complete our transform pieces setup here. I will duplicate an object merge, place our anim points here, and this will be our template points. Let's look at our transform pieces, and hopefully everything should be good. And I will untemplate everything. So now we can see all of the pieces are following their curves, and because we only edited one curve, this piece now flies like this. And let's just make sure that we end up in exactly the position where we started. And these are the pieces that we will render actually. So from here we can say, let's say out pieces, and this is what we will render. Of course, there's still a lot of stuff to do to make this better. We have to procedurally alter the shape of our curves, and we want to add additional attributes to drive certain effects for our points. But essentially, this is the setup. So let's go ahead with the next video and see how we can improve our setup.